Good. Okay. So, it's just a quick, example. I really hope it makes sense. I don't think it was too hard. I don't think that was too hard. All right. All right. So here's one I want everyone to actually try. So let me stop the recording. Okay, so here's another example that we can do. So here we want to convert. So again, in really, this is just in a sense, just a basic arithmetic, maybe not basic, but it's a algebra question. Essentially, here I'm giving you the temperature in degrees Fahrenheit, right? So this is going to go into F, and then you have to calculate C. Well, that's what these calculations are showing you. Okay. So as you can see, I'm showing the work here, right? What you want to do is replace 79 with F. I got it backwards. You want to replace F with 79. Then you want to solve for C. That's what you want to do. And that's what I'm doing here, right? I want to get C all alone. So I subtract 32 from each side, right? We're solving for C, so you have to isolate it. And we get 47 equals 1.8 times C. The next step, this is just, I guess, the mathematician part of me, but it's good to have the unknown on the left side. That's what I've been told by other mathematicians. So, if you forget to do that on an exam, I'm not going to take points off. But anyway, so I have 1.8 times C equals 47. And either way, you just got to divide by 1.8. And when you do that, you get C equals 26.11. So we get 26.11 degrees Celsius. So that's what we get here. Okay, I hope that made sense. I don't think that was terrible. So, all right. Yeah?
After you get 47 equals 1.8 C,
yeah.
What do you do?
What you want, I put the C on the left side because C is the unknown. You don't have to do that. You could keep it on the right side.
Yeah.
But either way, you just basically have to divide by 1.8.
Oh, okay.
Does that make sense? Or
for both sides or just one?
Both sides. Whatever you do to one, you have to do to the other side. You have to keep it in balance.
Okay.
Okay. Awesome question. Any other questions? All right. So basically here, what we're going to get to is we're going to look at rates. And a rate, as I have here, is really a type of ratio. We actually see this all around us. A ratio is really just a way of comparing two quantities. It's a relationship or a comparison of them. Even when you're driving, right? The speed limit might be, I don't know, 20 miles per hour. What does that mean to drive 20 miles per hour? It means at that speed, after an hour, if you drive at that speed for 1 hour, right, you would have driven 20 miles. Or like when you're baking something like I have here, right, they might say for every 2 cups of sugar, add a tablespoon of vanilla. That is technically a rate, okay? That's a ratio, okay? So a rate is really just a ratio of 2 quantities together, which we usually express as fractions, as I have down here. You have 25 miles per hour. We wrote that as a fraction, right? This is a rate. We have $2 per pound. In fact, these are special kinds of rates. These are what we call a unit rate. So a rate, again, is a ratio of 2 quantities. In particular, a unit rate, that is a ratio. That's a rate where the denominator is 1. That's a rate where the denominator is 1. Here, 1 hour per 25 miles, that's a rate. It's not a unit rate, but it's still a rate, though. You know, if you drive for an hour, you would have gone 25 miles. Okay. Or again, like you're going food shopping at Walmart, or what's another one here, Hannaford, right? You know, bananas might be $2 per pound, right? I mean, what does that mean? For every pound of bananas you buy, it's going to cost you $2, right? Or apples, let's say, you know, if you're buying apples, it might cost you $2 and, excuse me, $3 per pound, right? For every pound of apples you buy, it's going to cost you $3. You know, these are rates. Rates are all around us, is what I'm saying. Okay. Now, to work with rates, we are going to have to do some kind of, I guess, similar to the factor label method. Basically, we're going to have to multiply by these rates, as you'll see here. So let's suppose I'm driving, right? And my car can drive 300 miles on a tank of 20 gallons. Okay, so again, we know that my car can drive 300 miles on a tank of 20 gallons. Let's express this as a unit rate. Okay, we'll do that first. Then we're going to use that unit rate to determine how far I can drive if I have 35 gallons. So let's say my gas tank can hold more than 20 gallons. It can hold at least 35 gallons. Pretty big gas tank, I guess. I don't know. But, you know, again, this is all hypothetical, imaginary, so to say. And then we're going to figure out how many gallons do I need to drive 30 miles. So I'm going to show you one way to solve these. It's actually very similar to the factor label method in that the unit rate you're going to treat as a unit conversion and just multiply. Whoa, okay, awesome. So anyway, what we have for number one, right? We have 300 miles per 20 gallons, right? Now, if we want to write this as a unit rate, okay, what we want to do is get the denominator equal to 1. I know this stuff probably should have been below here, so I apologize if it's out of order, but hopefully you still get the idea. Namely, what we want to do is we can divide 300 by 20 and we get 15, which is really the same as saying 300 over 20 equals 15, right? And so that really tells us that 300 is 15 times 20. So essentially what we did was we factored 300 to 15 times 20, and then the 20s cancel. So we get 15 miles per gallon. Okay? I mean, again, you could write a 1 here. You don't have to, but it's a unit rate now. And essentially, we just had to get the denominator to be 1. So I did it by factoring, which is based on dividing. Does that make sense? Actually, let me ask this. Are there any questions so far? Yeah?
Wait. Can you explain the first line? The 300.
The first line is basically the work I did to get from 300 miles over 20 gallons to this, how I factored the numerator. Because 300 is equal to 15 times 20, and that's what this is showing. You just divide. Okay. So that's for the first part. Okay. Now, how do we get the number of miles, though, that we can drive if we decide to multiply? Excuse me. Sorry. We want to know how far we can drive on 35 gallons, right? You know, that's what we want to know. Well, we know we can go 15 miles per gallon. If we have 35 gallons, right, we want to know how many miles we can go. You just multiply. You can see that the unit gallons are going to cancel, and what we're left with is miles. So basically, we're just multiplying is what we're doing. It's almost kind of like saying when you do a unit conversion, if 15 miles equals 1 gallon, right, then for 35 gallons, to find out how many miles that equals, you multiply. It's kind of like a unit conversion. I mean, it's really not a unit conversion, but again, it just boils down to multiplying. because you can see the gallon unit, they're going to cancel, and we're left with 15 times 35 miles, which is 525 miles. So you could just multiply. And what I'm showing down here, even though in part 1 I asked for the unit rate, you really don't have to use a unit rate. So if we didn't have if we did not have 1 up here, we could still solve the second part. You could just still multiply. I mean, you have a little bit more arithmetic to do, 300 over 20 times 35, but you still get the same answer though. Again, it just boils down to multiplying, and the unit gallons cancel. So it's kind of like a factor label method.